day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we'll be focusing on matter and material, which has a total of 47 marks. And for today's topic, we will be focusing on the physical properties. Okay, so the mark allocation for paper 2 is distributed in this way. We have section A, which has 5 multiple choice questions and has a total of 10 marks. Then we have section B, which consists of structured or long questions and has a total of 65 marks. Now the total for paper 2 is 75 marks with a duration of 1 hour, 30 minutes. Topics covered in paper 2 will be matter and material, which has a total of 47 marks and a percentage weighting of 62. Then we have chemical change, which has a total mark of 28 and a percentage weighting of 38 there. So just to remind you on the homologous series and the functional groups that you need to know. So remember, throughout organic chemistry, you need to know this table off by heart. So for the homologous series, we have alkanes, and for the alkanes, you need to know the structure of the alkanes. And then the alkanes contain what? They contain single bonds. So where are those single bonds? They are in between what? The single bonds are in between the two carbons. Then we have the alkenes. So the alkenes, what is the name of the functional group of the alkenes? So the name of the functional groups of the alkenes are therefore carbon-carbon what? Carbon-carbon, double bonds. Why? Because they contain double bonds between the carbons there. Next we have the alkynes. Alkynes, as we can see here, they have what? They have triple bonds. And therefore, the name of the functional group will therefore be a carbon-carbon triple bond. And then next, you need to know the structure of the what? Of the haloalkanes. So haloalkanes, the X there on the haloalkane, it represents what? It represents the halogen. So for the halogen, we have your fluorine, chlorine, bromine, and your iodine. Then next we have your alcohol. So how do you see an alcohol? You will identify an alcohol with the OH group, and therefore we call that what? We will call that a hydroxyl group. Then next we have alkanes. The alkanes, they have what? They have a C double bond O and then H, and then normally where are you going to find this? The C double bond O and the H will normally be at the end of the molecule, or it's going to be at the start of whatever compound that you are dealing with. Then the aldehydes, the name of the functional group is called what? They are called the formal group. Then next we have ketones. So ketones, what do they have? How do you identify them? They have a C double bond O, but that C double bond O is in between what? It is in between two carbons. As you can see here, we have a carbon on the left, a carbon on the right, and then in the center we have what? We have a C double bond O, and the name of the functional group is therefore called what? A carbonyl group. Next we have carboxylic acids. So carboxylic acids, they have a C double bond O and then OH, and then where are you going to find that? It's either going to be in the beginning of the structure or at the end of the structure, the C double bond O and the OH. So these ones, they are therefore called the carboxyl group. Then we have esters. How do you identify esters? So esters have C double bond O and then O, and where is it normally going to be? It's normally going to be in between what? In between two carbons. So normally on this side here, you will have a carbon, so as well as on the right, so the left and the right, you are going to have carbons, and then in between the two carbons, that is where you have the what? That is where you have the C double bond O, and the O, unlike the carboxylic acids, the carboxylic acids are what? They are just C double bond O and the OH, and that is going to be in the beginning of the structure, or it's going to be appearing where? At the end of the structure. So whenever you prepare yourselves for the examination, you need to keep this table in mind. Then for IUPAC naming, or for the full name is International Union of Pure and Applied Chemistry. This is what you need to know. For the alkanes, remember alkanes, they end with what? They end with the A. So therefore, if you are to name, you need to remember to add what? To add the ane at the end of whatever name that you have there. Then for the alkenes, you are just going to replace the ane with the what? With the in. And then alkynes, you are going to replace, if it was an alkane, it ends with the ane, but then if it's an alkyne, you are just going to replace the ane with the ine. Then we have alkyl halides, or also called the haloalkanes. So for the haloalkanes, they have a name ending that is similar to your alkanes, so therefore they also end with what? They also end with the ane. Then we have aldehydes. So again, if this was an alkane, so if you have an aldehyde, you are just going to replace what? You are going to replace the E of the alkane with the al for the aldehydes. And then for the ketones, again, if it was an alkane, you would have a pentane, but again, you would replace the E with the what? With the on or with the one. Then for the alcohols, remember we have a primary alcohol, secondary alcohol, and also a tertiary alcohol. So the alcohols, they end with the what? Again, you remove the E from a alkane, and then you replace the E with the what? With the ol. Carboxylic acids, so the carboxylic acid, they end with the what? They end with the oic acid. So if you have an alkane, you replace again the E with the oic acid, and then the last one there is the esters. So again, for your question 2, your question 3, your question 4 of organic chemistry, when you are dealing with those questions, then you need to keep the following in mind as well. So learners, if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. So next here we have physical properties. It says the shape. So we have the shape and the structure of an organic molecule, as well as how many carbon atoms it has, are just some of the factors that affect its physical properties, such as the melting point, the boiling point, and the physical state as well. So these are some of the physical properties that we are going to look at. That is the boiling point, the melting point. We are also going to look at the vapor pressure, and again we are also going to look at the viscosity. So we have what we call intermolecular forces. And then it says intermolecular forces are the attractive forces that are there between what? Between the organic molecules. So when it comes to the physical properties and the intermolecular forces that we have what we call the van der Waals forces. And under the van der Waals forces, we have two types. We have the London forces, and then we also have the dipole forces. So how do you differentiate between the two? The London forces, they are very weak intermolecular forces, and then the dipole forces are therefore slightly strong as compared to the London forces. And then we have the third one, which is called hydrogen bonding or hydrogen bonds. So therefore those ones are the strongest amongst the three. So in terms of strength, then it means that we are going to be moving from the left hand side of the table to the right hand side, starting with the London forces, which are weak intermolecular forces. Then we have dipole forces, which are slightly strong. So it means that dipole forces are going to be stronger than what? Are going to be stronger than the London forces. And then it also means what? The hydrogen bonds are going to be stronger than what? Than the dipole forces and the London forces. So under the London forces, this is what you need to know, that we have alkanes, then we have alkenes, and then we have what? Then we have your alkynes. So the way that you can also memorize this, then you can also use these highlighted words. So therefore, it will then be what? Your triple A. So triple A would therefore be your alkane, your alkene, and then your what? Your alkynes. Then under the dipole forces, again, using the highlighted words are what we have hake. So using the word hake, then the H would represent your haloalkane, the A would represent your aldehyde, your K would represent your ketone, and then your E would represent your what? Your esters. Then in terms of strength again, we said in terms of the intermolecular forces, we are going to be moving from the left to the right. So when it comes to this one, in terms of the strength, we are going to be moving from the top. We are going to be moving from the top and then we're downwards. So again, we are going to be moving from the top and then we're downwards. So that is in comparison with the strength. And then the last one, under hydrogen bonds, so you need to know that we have alcohol. So alcohols, they contain one site for hydrogen bonding, and then we have carboxylic acids. So your carboxylic acids, they contain two sites for hydrogen bonding. And then this one, how can you remember it? You can use your AC. So the first one for the London forces, we said you can use your triple A, so that is alkane, alkene, and alkyne. And then this one, we said you can use what? You can use the word hake. So your hake will be haloalkane, aldehyde, ketones, and esters. And then for the last one, you can then use what? You can then use AC. So triple A, hake, and what? And AC. So the AC would be your alcohol, and then your the A would be your alcohol, and then your C would be representing your carboxylic acids. So for this topic, again, when you get to the exam, you need to make sure that you know this table off by heart, because it is going to make the topic and the question easy for you. Okay, then for the definitions, we need to know the definition of vapor pressure. It says the pressure exerted by a vapor at equilibrium with its liquid in a closed system. Then we need to know the definition of boiling point. It says the temperature at which the vapor pressure equals the atmospheric pressure. Then melting point, the temperature at which the solid and liquid phases of a substance are at equilibrium. Then we need to know the definition of viscosity, which says the property of a fluid to oppose relative motion between two adjacent layers. So remember the definitions. According to your examination will be 2 marks. So you are not going to be getting half mark or 1 out of 2 marks. So you need to make sure that you know the full definition as it is. Then again, you need to note the following. So we spoke about the intermolecular forces. We said we have the London forces, followed by the dipole forces, followed by what? By your hydrogen bonding. So the very same intermolecular forces, it says here, note, as the strength of the intermolecular forces. So the very same intermolecular forces that we spoke about, as the strength increases. So as the strength of the intermolecular force increases, what is going to happen to the vapor pressure? The vapor pressure will do what? The vapor pressure decreases. And then what is going to happen to the melting point, boiling point, and the viscosity? They are going to do what? They are going to increase. So what is the relationship that you can see here? I will just repeat for you. So in terms of the strength of the intermolecular force, we are saying as the strength of the intermolecular force increases, then the melting point, the boiling point, and the viscosity are going to do what? They are going to increase. So if we were speaking about paper 1, then we were going to say they are directly proportional. But remember in chemistry, when you write it or when you state it, you need to say as one increases, the other one will increase as well. So again, if we are to look at the relationship between the intermolecular force and the vapor pressure, if we were speaking in terms of paper 1, we would say that as the strength of the intermolecular force, we would say that the two, the intermolecular force and the vapor pressure are what? Are inversely proportional. But remember again in chemistry, when we state it, we are going to say as the intermolecular force increase, then the vapor pressure will do what? It will decrease. And then as the intermolecular forces increases, then the melting point, boiling point, and the viscosity are going to do what? They are going to increase. So you need to keep the following in mind, right? To say the boiling point, melting point, and the viscosity, they go hand in hand. But then the melting point, boiling point, and the viscosity, they are inversely proportional to the what? They are inversely proportional to the vapor pressure. But again in chemistry, we say what? We say the melting point, boiling point, and viscosity, as they increase, then what will happen to the vapor pressure? The vapor pressure will do what? The vapor pressure will decrease. So again, you need to keep the following in mind. Then this is also just to guide you in terms of how to answer the questions when you have, that is going to be your question 3. So you can use ICE, whereby I will represent, or it says here, give the type of what? Of intermolecular force. So the I in this case would be represented by what? By intermolecular what? Intermolecular force. So with I, you need to give the type of intermolecular force. For example, do you have London forces? Do you have dipole forces? Or do you have your hydrogen bonds? And then the I again can also mean that you need to talk about your independent variables. Then by C, we are saying that you compare the strength of the intermolecular forces. So comparing the strength means that before you compare them, then you need to do what? You need to give the type of intermolecular forces. So by I, we said you are going to give the type of the intermolecular forces to say you have London, you have dipole, or you have hydrogen bonds. Then by C, after you have now stated the type of intermolecular force that you have, that is then where you can then compare to say, okay, hydrogen bonds is therefore stronger than what? Than dipole force. Or dipole force is therefore stronger than what? Than London force, or hydrogen bonds is stronger than what? Than your London forces. Then E, that is where you talk about what? That is where you talk about your energy. So with energy, that is where you need to state, do you have more energy? Remember, it's more energy to do what? To overcome the intermolecular forces, or do you have less energy to overcome what? To overcome the intermolecular forces. So with this ICE or with this ICE, you can then be able to answer. It's normally a 3 marks question or your 4 marks question in question 3 of your paper 2. Then the variables. So we have the independent variable, that is what you are changing. And then for the independent variable, so the independent variable, it goes hand in hand with the I, or with you giving the type of intermolecular force. So it goes hand in hand with this I here by the ice. So you can use this IF chain more, whereby the capital letter I here, it represents the intermolecular forces, the F represents your functional group, and then this is the chain, the MO, which represents your molecular mass, and then the last capital letter B would represent whatever branches that you'll be having. Then we have your dependent variables, so that will be whatever that you will be measuring. So our dependent variable, they are going to be your melting point, the vapor pressure, and also the boiling point there. So it says here boiling point, melting point, vapor pressure, and the viscosity in relation to the following. So number 1, the strength of the intermolecular forces. So in terms of the strength, then remember we spoke about London forces, dipole forces, and then we spoke about what? Hydrogen bonds. So under London forces, remember we said we have your triple A. Then under dipole forces, we said we have Hague. Under hydrogen bond or bonding, we said we have your AC. Okay, so in terms of the strength of the intermolecular forces, if you have weak intermolecular forces, for example, we can use what? We can use dipole forces. So remember dipole forces, under dipole forces we have what? We have your Hague. So if you have weak intermolecular forces, then what does it mean? It means that less energy is required or needed to overcome the intermolecular forces. Okay, so if less energy is required to overcome the intermolecular forces, then it means that the boiling point, the melting point, and the viscosity will be low. If the boiling point, melting point, and viscosity are going to be low, it means that you are going to have what? You are going to have a high vapor pressure. So dipole forces, they are weak intermolecular forces. If they are weak, it means that less energy is required to overcome the intermolecular forces. Then again, in terms of the boiling point, melting point, and the viscosity, they are going to be low. If they are low, it means that the vapor pressure will be what? Will be high. Then if you have strong intermolecular forces, so as an example, if you have hydrogen bonds, remember hydrogen bonds are stronger than what? Than dipole-dipole forces. So if you have strong intermolecular forces, as an example, hydrogen bonds, then more energy is needed to overcome the what? The intermolecular forces. So they are opposites. Therefore, it means that you are going to have a high boiling point, melting point, and the viscosity, but it therefore means that you are going to have what? A low vapor pressure. So that is our number one in terms of what? In terms of the strength of the intermolecular forces. So number two, for the type of functional groups. So again, remember we have London forces, and then under London forces we have AAA. So under that AAA, the first one is what? The first one there is your alkanes. So for alkanes, they are weak intermolecular forces. Again, if you have weak intermolecular forces, what does it mean? Less energy is needed to overcome the intermolecular forces. If less energy is needed to overcome the intermolecular forces, how is it going to impact your boiling point, melting point, and viscosity? It means that they are going to be low, and if they are low, it means that the vapor pressure will be higher. So again, remember, you just need to keep the relationship of the following in mind: the boiling point, melting point, and viscosity. As the boiling point increases, the melting point will also increase, and the viscosity will also increase. But if the three are going to increase, it means that the vapor, if the three are going to decrease, it means that the vapor pressure will do what? The vapor pressure will increase. Then we have, if we have strong intermolecular forces. So remember, the last column there was what? Your hydrogen bonds, and then under hydrogen bonds we have what? We have alcohols. So with your alcohols, we are saying they're stronger than what? Than your alkanes. So if they're stronger, it means what? More energy is needed to overcome the what? The intermolecular forces. So if more energy is needed to overcome the intermolecular forces, then it means that you are going to have a high boiling point, melting point, and a high what? A high viscosity. So if the three are going to be high, it therefore means what? It therefore means that you will have a low vapor pressure. Okay. Then we have the chain length. So if we have a short carbon chain, short carbon chain can, for example, mean that maybe you have 2 carbons as compared to a longer chain. So if maybe this one has 2 carbon chains, this one, for it to be longer, it means that it has to have what? 2 carbons or more, 3 carbons or more. So maybe, for example, this one can therefore have what? Like 4 carbons. Then if you have a short carbon chain, we said as an example, if you have whatever carbon chain that has 2 carbons, then it means that you have weak intermolecular forces. So if you have weak intermolecular forces, what does it mean? Less energy is required to overcome the intermolecular forces. So therefore, you'll have a low boiling point, melting point, and a viscosity, but you'll have what? You'll have a higher vapor pressure. Then if you have, so for this one, we said if you have 2 carbon chains, so if you have 4 carbon chains on this one, it means that 4 carbon chains will have stronger intermolecular forces as compared to what? As compared to 2 carbon chains. So 4 carbon chains, what will it mean then? It will mean that more energy is needed to overcome the intermolecular forces. Therefore, you'll have a high boiling point, melting point, and viscosity, but you'll have what? You'll have a low vapor pressure. Okay, and then the next one, So if you have branch chains, so this is now our number 4. If you have a branch chain, so let's say this one, it is branch, and then this one, if it's not branch, it means that it is just going to be what? It is going to be a straight chain. So if you have branched chain for the first one here, it means that you have what? You have weak intermolecular forces. If you have weak intermolecular forces, what does it mean about your energy? Less energy is needed to overcome what? The intermolecular forces. If less energy is required to overcome the intermolecular forces, then what are we going to do? It means that you'll have a low boiling point, melting point, and viscosity, but you are going to have what? You are going to have a higher vapor pressure. So if you maybe also want to make this easy for yourself, you can therefore draw what? You can therefore draw arrows as well to say that so for everything that is at the top here, you have what? You have a low vapor pressure. Sorry about that. So therefore the arrow will be facing downwards, and therefore you will have a low boiling point, melting point, viscosity, but you'll have what? You will have a high vapor pressure. The same goes for this one. So you'll have a high boiling point, melting point, viscosity, but you'll have what? You'll have a low vapor pressure. So with this one, we are saying if you have strong intermolecular forces, but you have a straight chain. So if it's not branched, then it will just be a straight chain. When it is a straight chain, then what will happen in terms of the energy? More energy is required to overcome the intermolecular forces. So maybe just to also clarify on this one, on the more energy is needed to overcome the intermolecular forces. Remember, we do not break the bonds. So the correct words for you to use will be more energy is needed or is required to do what? To overcome, not to break the bonds. So to overcome the intermolecular forces. So whenever you see more energy, therefore it means what? You will need what? You will have a high boiling point, melting point, viscosity, and therefore you'll also have what? You'll also have a low vapor pressure. So we are going to do this activity together. It says the boiling points of organic compounds A, B, and C from different homologous series are given in the table below. Okay, so what are we given? We are given compound A, we are given compound B, and we are also given compound what? Compound C. But with compound A, B, and C, what are we given? We are given the different boiling points. So we are not told the homologous series of what? Of the compounds. And then 3.1 says define each of the following terms. So the first one there is what? Is 3.1.1. We need to define homologous series. So remember, when you define according to the examination guidelines, because the definition will be 2 marks. You are not going to be getting what? Half a mark. So homologous series, it says, is a series of organic compounds that can be described by the same general formula, and where each member differs from the next by what? By a CH2 group. And that is for what? That is for your 2 marks there. Then 3.1.2, you need to define a boiling point. Then it says here the temperature at which vapor pressure equals atmospheric what? Atmospheric pressure. And again, definition is what is 2 marks there. Then the next one says, which compound A, B, or C will have the lowest vapor pressure? And then it says you need to explain what? Explain the answer. Okay, so you are going to go back to what? You are going to go back to the table. And then you are going to use your knowledge of what you know about what? Of what you know about the boiling point and what? And vapor pressure. So what is it that we have learned? We have learned that the boiling point, the melting point, and the viscosity, they are directly proportional, or as one increases, as the boiling point increases, the melting point will increase, and the viscosity will do what? It will increase as well. But all the three, if all the three increase, then the vapor pressure will do what? The vapor pressure will decrease. Okay. So the question says, which compound A, B, or C between the three will have what? Will have the lowest vapor pressure? So as we have just stated now, the one that has what? The one that will have the highest boiling point is the one that is going to have what? The lowest vapor pressure. So it says here it's going to be C, because C has what? C has the highest boiling point. So how do we know that? We can see that this one is negative 89. So negative 89 is smaller than what? Is smaller than 78. So therefore the highest vapor pressure can only be what? 118,50, which is what? Which is C. Then what is it that you know? It says as the boiling point increases, the vapor pressure will do what? The vapor pressure will decrease. So as one increases, the other one will decrease. Then 3.3, which compound A, B, or C is a gas at room temperature? Okay, so which one will be a gas at room temperature? So on this table here, what is it that we are looking at? We are looking at the boiling point. And then now you must think about what is the temperature, what is the room temperature. So a room temperature will be about 25 degrees Celsius. So it means that if the compound is already at a boiling point, so remember the different phases that we have. The different phases that we have, we are going to have a solid. So if you can think of an ice cube, you have a solid. And then what will the solid do? The solid will then melt. When it melts, that is where you are going to have what? That is where you are going to have a liquid. After melting, the solid will then increase in temperature where it is boiling, and then that is where you will be having what? That is where you will be having a gas. So if already, if this represents what? If this represents the boiling point, so it means that after boiling, then that compound will therefore become what? It will therefore become a gas, right? So it means that we need to look at all of these temperatures. So for option A, option B, and option C to say which one after boiling can therefore become what? Can therefore become a gas at room temperature. And then what is that room temperature? So we said that room temperature will be what? Will be about 25 degrees there. So looking at the three, this one, letter A, it says its boiling point is what? Its boiling point is 78. So boiling point, looking at this arrow here, it means that already the 78 is what? It is above the 25 that we are looking for. And then if we look at this one, letter C, the boiling point of letter C is what? Is 118,50. So already 118.5,0 is above what? Is above the 25 that we are looking for. But if we look at letter B is negative what? Is negative 89. So it means that after negative 89, it is therefore going to pass what? It is therefore going to pass 0. And after passing 0, that is where we are going to have what? That is where we are going to have our 25 degrees. So the only option that we have there will be what? Will be the letter B. Then 3.4, it says the homologous series to which the three compounds A, B, and C belong were identified in random order as ethanoic acid, ethanol, and ethane. Then it says, what is the boiling point of ethanoic acid? So again, you need to use that table that we started with to arrange the following. So remember, we said we have London forces, and then under London forces, we said we have what? We have triple A. So already we can see that the ethane, where does it belong? It belongs under the triple A, which is your alkane, alkene, and what? An alkyne. Then, so we said we have dipole forces. Under dipole forces, we said we have Hague. Then we said we have the last column, which is your hydrogen bonds. And under hydrogen bonds, we said we have what? We have your AC. So under AC, we said we have alcohols and what? And your carboxylic acids. So the question says, what is the boiling point of what? What is the boiling point of ethanoic acid? So how do we then approach this one? It means that the boiling point of ethanoic acid will be the 118,50. Why? Because in terms of strength now, you need to remember the strength. Remember we said it's going to be London forces, then dipole forces, and then what? And then our hydrogen bonds. So in terms of strength, the one that will have the lowest boiling point will be what? Will be your ethane. Ethane falls under your London forces. And then under hydrogen bonds, we have what? We have alcohols and what? And carboxylic acids. But remember, we said your alcohol has what? It has one side for hydrogen bonds. And then we said your carboxylic acid has two sides for hydrogen bonding. So therefore, it means that the carboxylic acid will be stronger than what? Will be stronger than the alcohol. So between the two, letter A and letter C, if you are then to check which one is your carboxylic acid, we are saying it is going to be the one with the highest boiling point. Why? Because carboxylic acid, your ethanoic acid, is stronger than what? It will be stronger than your alcohol. Why? Because we are saying your alcohol has one side for hydrogen bonding, while your ethanoic acid is a carboxylic acid, so it has two sides for what? For hydrogen bonding. Then we have 3.4.2. It says compare the boiling points of ethanoic acid and methane by referring to the type of intermolecular forces and the energy required. Okay, so we are comparing the boiling points of the two. The boiling point of what? Of the ethanoic acid, and the boiling point of what? Of the ethane. But when we do the comparison, it says we need to refer to the type of intermolecular forces, and we need to refer to what? We need to refer to the energy. So how are we going to answer this one? So firstly, we need to state what we know. So what is it that we know? So remember, going back to the ice. Remember that we said the ice can mean the independent variable, or it can mean, to make it easier, we said we can talk about the type of intermolecular forces. So it means that when we answer this question, then we need to start by stating the type of intermolecular forces that are there. So the type of intermolecular forces that we have in terms of the ethanoic acid, and the type of intermolecular forces that we have on the ethane. So for the ethanoic acid, remember we said ethanoic acid on the last column. We said ethanoic acid is a carboxylic acid. So therefore, it says ethanoic acid has two sides for what? For hydrogen bonding. Okay. And then our ethane, we said you'll find it on the first column, that is your AAA. The first one there on the AAA is what? Is your alkane. So ethane has what? It has London forces. So we start by stating what we know. What is it that we know? We know that ethanoic acid will belong where? Under hydrogen bonding. But it has two sides for what? For hydrogen bonding. And then we know that ethane has what? Has London forces. Then after stating what we know, we are then going to do what? We are then going to compare. So it says here hydrogen bonds in ethanoic acid is stronger than the London forces in what? In ethane. So we are comparing now. Remember we said on the table that the strength of the intermolecular forces will increase from the left to what? To the right. So meaning the hydrogen bonds will be stronger than the London forces. So we are comparing. But remember, you cannot compare if you do not know what you have. So that is why we start by stating the type of intermolecular forces. After stating, we are comparing. After comparing, that is when we can talk about what? That is when we can talk about the energy. So the last part says here, more energy is required to overcome the intermolecular forces where in ethanoic acid than in the ethane. So we spoke about that one. More energy will be required in the ethanoic acid. Why? Because ethanoic acid has stronger intermolecular forces as compared to what? To the ethane. Then we make a conclusion. It says hence ethanoic acid has what? Has a higher boiling point than what? Than your ethane. So because it's 4 marks, then it means you will get a mark for stating the type of intermolecular force that we have on the ethanoic acid, the type of intermolecular force that we have on the ethane, for comparing, and then the last mark will therefore be given for the energy. So again, learners, if you have any questions, you can send your questions to the following WhatsApp number 0635081301. If you have any questions, learners, you can send your questions to the following WhatsApp number 0635081301. Okay. Then the next one here says the table below shows the vapor pressure of various organic compounds at 25 degrees. Then it says, so we are given the compounds, we are given the molar mass of the compounds, and then on the last column we are given what? We are given the vapor pressure. So 3.1 says write down the what? The general formula of the homologous series to which what? To which pentane belongs. So what are they looking for? They are not looking for the homologous series, but they are looking for a formula. Which formula? The general formula to which pentane belongs. So remember I said you must memorize the what? The name endings. or you must know the name endings off by heart actually. So if we have an A, it means that what is the homologous series of the pentane? The homologous series of the pentane is therefore what? Is therefore an alkane. So you need to write the what? The general formula of the alkane. What is the general formula of the alkane? That will be your CnH2n plus what? Plus 2. And please learners, you are not going to write it in this way. Therefore, you will not be given a mark for that. So you must be careful as to how you write your n and your 2n plus by what? Plus by 2 then. Then 3.2 says draw the structural formula of what? Of propanol. So propanol, again, before you do anything, you need to identify what? You need to identify the homologous series. So if it's propanol, the name ending is on or the name ending is 1. So therefore it means that this must be a what? This must be a ketone. Then you can think about the structure of a ketone. What do you know about a ketone? A ketone has what? A ketone has C double bond what? C double bond O, but this C double bond O, it must just be between what? It must be between 2 carbon atoms. And then you move on to the next one to say it is prop. So if you have a prop, it means that you have how many of the carbons? It is going to be what? It is going to be 3 carbons. So you have the structure C double bond O, it's in between 2 carbons. Then prop, it means that it's going to be 3 carbons, and then you can therefore be able to add the rest of the hydrogens. So the question says we need to draw a structure. So you are therefore going to draw what? You are therefore going to draw the structure. So this is what we have. If I am to complete this one, this carbon only has 1 bond. So therefore, to add the hydrogen, it will therefore have a total of what? A total of 4 bonds. And then this one, the carbon that is in the center, or this one, already it has 1, 2, 3, 4 bonds. So that is why we are not going to add another hydrogen at the bottom there. And then the one on the right only had 1 bond, so therefore we are able to complete it and add the 3 what? The 3 hydrogens, on the last carbon there. Then 3.3 says give the name of a functional isomer of what? Of propanol. So they want a lot of things here. The first thing here, it says you must give the name. Then they want what? But that name must be of what? Of a functional isomer. Okay? But that functional isomer is the functional isomer of what? Of propanol. Okay? So remember when we have to give the functional isomer, we said we are going to use what? We are going to use CAKE or cake, whereby this will represent what? This will represent your carboxylic acid, this one your aldehyde, your ketone, and then this one your ester. So remember we said carboxylic acids, they go hand in hand with the esters, and then we said aldehydes, they go hand in hand with what? With the ketones. So it says that we need to give the name of the functional isomer. So it means that we are going to be working from where? We are going to be working from the propanol. We are going to be working from the propanol that we previously had. So this propanone, what is the homologous series of this propanone? It is a ketone. So we can see that, okay, we are working with the K there from the cake, and then from this ketone then, what is it that we are going to have? We are going to form or to draw what? An aldehyde. So how do we draw the aldehyde? The aldehyde will have the same number of what? Will have the same number of carbons. So remember, we said with an aldehyde, we are going to have what? You are going to have a C double bond O and what? And then H there. So that is where you start with your aldehyde. Then from there, what are you going to do? You can add your hydrogens there, add your hydrogens, so that each carbon has a total of what? Has a total of 4 bonds. So from there, to check if your structure is correct, what is it that you are going to do? You can then count the number of carbons that you have. So for the one on top there, how many carbons do we have? We can see that we have 1, 2, 3 carbons. So what are we going to write? We are going to write C3, and then therefore C3H, 1, 2, 3, 4, 5, 6, 6 hydrogen and 6 hydrogens. And how many oxygens do we have? We have what? We have 1 oxygen, so we just write our oxygen there. And then we come on to the aldehyde. So with the aldehyde, how many carbons do we have? We count again, it's 1, 2, 3 carbons. And then how many hydrogens do we have on the aldehyde? 1, 2, 3, 4, 5, 6 hydrogens. So we physically count. And then how many of the oxygens do we have? We have 1 oxygen. So therefore this is the molecular formula. So if you want to find the functional isomer, firstly you will draw the structural formula of what? Of the propanone. From the structural formula of the propanone, we said we are going to use the word K. So we said K is a ketone, and a ketone, it goes hand in hand with what? With A, which is what? Which is our aldehyde. And then we said C is carboxylic acid, it goes hand in hand with what? With E, which is the ester. But right now we are using what? We are using K and what? And A. So we said if you have a ketone, then you need to draw the structure of what? Of an aldehyde. So we have done that. But if you want to verify that your structure is correct, what is it that you are going to do? Then you need to draw the molecular formula. So we have done that. So the molecular formula of the ketone is the same as the molecular formula of the aldehyde. So it means that our structure is what? Our structure is correct. Okay. So now going back to the question, it says, give the name of the functional isomer. So now that we have the structure of the functional isomer, we can therefore be able to do what? To give the name of the functional isomer of what? Of propanone. Okay. So the name of the functional isomer of propanone will therefore be the name of what? Of this structure. So the name of the structure, we can see that it's an aldehyde, so it will therefore be what? Propanal. Then 3.4, it says write down the name of the intermolecular forces that are involved in the following. So again, we'll go back to what? London forces, AAA. Dipole forces, Hague. Hydrogen bonding, what do we have? We have AC. So you need to recall all of that. So 3.4.1, hydrogen bonds, the last column under hydrogen bonds, what do we have? We have your alcohol and what? And your carboxylic acid. So that is why for 3.4.1, our answer there will be what? Will be your hydrogen bonds. Then 3.4.2, remember, London forces AAA. The first one under AAA is what? Is your alkanes. So that is why our answer for 3.4.2 will therefore be your London forces. Then 3.5, it says refer to the table of organic compounds above to state and explain the relationship between vapor pressure and the strength of the intermolecular forces. So remember, we spoke about this one. We said in terms of the strength of the intermolecular forces, if you are going to compare the boiling point, melting point, and the viscosity, so if all of those ones are going to increase, therefore the vapor pressure will do what? It is going to decrease. So again, with the strength of the intermolecular forces, it says here, as the strength of the intermolecular forces increases, the vapor pressure will do what? The vapor pressure will decrease there. Then 3.6 says, which compound will have the higher boiling point between ethanoic acid and propan 1-ol? So we are looking at the following: ethanoic acid and propan 1-ol, and then it says, explain, referring to what? To the intermolecular forces and what? And energy. Okay, so again, London forces, AAA, dipole forces, Hague, and then the last column is what? Hydrogen bonding with what? With AC. So AC, it's alcohols. What do you know about alcohols? They have one side for hydrogen bonding, and then what do we know about what the carboxylic acid? They have two sides for hydrogen bonding. So looking at this one, the ol is what? Is an alcohol, and then the oic is what? The oic is a carboxylic acid. So it says here, ethanoic acid has two sides for hydrogen bonding. Ethane has what? Ethane has London force. Ethane has London forces. Okay, sorry about this one. So it should be propanol. Propanol has one side for hydrogen bonding. So propanol has one side for hydrogen bonding, and then the ethanoic acid has what? Has two sides for hydrogen bonding, and therefore it will mean what? It will mean that in terms of energy, the ethanoic acid, more energy is required to overcome the intermolecular forces in the ethanoic acid as compared to what? As compared to the propan 1-ol. And then it therefore says, hence ethanoic acid will have a higher boiling point than what? Than the propan 1-ol. So again, when you write this question, what is it that you are going to do? You are going to state what you know. So the type of intermolecular forces. So the type of intermolecular forces by ethanoic acid is what? Is hydrogen bonding, but it has what? It has two sides for hydrogen bonding. And then the type of intermolecular force that we have by the propan 1-ol is what? Is hydrogen bonding, but it has what? It has one side for hydrogen bonding. So therefore, where are you going to require more energy? More energy will be required by the ethanoic acid as compared to the propan 1-ol, and therefore hence ethanoic acid will have what? Will have a higher boiling point as compared to the propan 1-ol. Okay. Then question 3, it says the boiling points and viscosity of organic molecules are given below. So for 3.1, we need to define the term viscosity. So it says here, the property of a fluid to oppose what? Relative motion between two what? Between two adjacent layers. So remember, for the definitions, you are going to give a full definition, because the mark allocation is what? You are going to get 2 marks or nothing, because remember, you cannot get what? You cannot get half a mark for the definition. Then 3.2, it says give 2 factors that affect the viscosity of organic molecules. So number 1 will be what? Your temperature, and number 2 will be the shape of the molecule. So you need to keep the following in mind. And again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number, 063-508-1301. So with that said, learners, we are going to take a 2 minutes break. So we are going to take a 2 minutes break, learners. Welcome back, learners. So again, if you have any questions, you can send your questions to the following WhatsApp number, 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number, 063-508-1301 there. So 3.3 says, explain the difference in resistance to flow between what? So now we are comparing methane and what? And propanol. Then it says we need to refer to the type and the strength of the intermolecular forces. And then we also need to talk about what? We also need to talk about the viscosity. So what is it that we know? We are going to state what we know about what? About methane and what? Methane and propanol. So again, we are going to refer to what? London forces, AAA. Under AAA, the first one that you find there is what? Is your alkane. So under the alkanes, we have what? We have methane, and then we have dipole-dipole forces. Under dipole-dipole forces, what do we have? We have the Hague. The Hague is your haloalkane aldehydes, ketones, and then what? And then the E is your esters. So ketones is there where under the dipole-dipole forces. So we first start by what? By stating. So when we state methane contains what? It contains London forces. And then propanol contains what? It contains dipole-dipole forces. Therefore, propanol has stronger intermolecular forces. So it has stronger intermolecular forces compared to what? Compared to methane. And then therefore methane will therefore have what? A lower viscosity as compared to the propanol. So what did we use again? We used the I's, whereby I, we were stating what we know, and that is the type of intermolecular forces that each have. So for ethane, the type of intermolecular force that is there is what? Is London forces. And then for propanol, the type of intermolecular force that is there is what? Is the dipole-dipole forces. So from there, after stating what we know, what did we do? We then compared. So when we were comparing, we said propanol has stronger intermolecular forces as compared to what? As compared to the methane. But then on this question, they did not ask about what? They did not ask about the energy. But already we have a mark for this one, for the type, and a mark for what? And a mark for comparing. But if they asked about the energy, then what were you going to say? You were therefore going to say more energy is required to do what? To overcome the intermolecular forces were by the propanol as compared to the methane, or more energy is required to overcome the intermolecular forces that are by the dipole-dipole forces as compared to the London forces. So therefore, our last statement, it says here that it should be based on what? It should be based on the viscosity. So therefore, it says methane will therefore have what? A lower viscosity as compared to what? As compared to the propanol. Because remember, the viscosity, so the viscosity goes hand in hand with what? With the melting point, and it also goes hand in hand with the boiling point as well. So if the three are going to increase, viscosity, boiling point, and the melting point, so it therefore means that the strength of the intermolecular forces will be what? Will be lower. So when you think about the methane, we said when we compare the strength of methane and propanol, which one is the weakest? Methane has weaker intermolecular forces. So if it has weaker intermolecular forces, therefore the what? The viscosity as well will be lower. Then 3.4, it says, what is the relationship between the boiling points of the organic molecules and the viscosity? So it says here, the higher the viscosity, the higher the what? The higher the boiling point. Or the lower the viscosity, the lower the what? The lower the boiling point. So they go hand in hand. So we said again, melting point, boiling point, and the viscosity, they go hand in hand, meaning as the velocity increases, the boiling point will increase, and so will the what? And so will the melting point also increase. But then we said if we are going to compare the three with the vapor pressure, as the three are going to increase, the vapor pressure will do what? The vapor pressure will decrease. Then 3.5, it says, what will be the influence on the strength of the intermolecular force of an organic molecule B if the molecule is or have branches, or it is branched? So what will be the effect of the intermolecular forces, or the influence of the intermolecular force? Then it says branch chain molecules, they have what? They have less surface area than what? Than molecules with straight chains. Therefore, branch chains will have what? Will have what? Weaker intermolecular forces. So if branch chains are going to have weaker intermolecular forces, it means that if we are going to compare a branch chain and a straight chain, then the straight chain would therefore have what? Would therefore have a stronger intermolecular forces. 3.5.2 says, so the influence of the strength of the intermolecular forces, B, if the molecule is or have a smaller molecular mass. It says a small molecular mass has or will have weaker intermolecular forces. So if you have a bigger molecular mass, it means that in terms of the strength, then it's the opposite, then you will be having what? Stronger what? Intermolecular forces. Then activity 4 here says 3.3, consider the graph below that indicates the boiling points of what? Of alkanes and aldehydes. Okay, so we are given the following graph and it says boiling point versus what? Versus the number of what? Of carbon atoms. And then on the y-axis, what is it that we are given? We are given the boiling point. And then on the x-axis, what are we given? We are given the number of carbon atoms. So it means that the number of carbon atoms is increasing as we go to the right there. But what does it mean again? It means that as we go up, the boiling point is doing what? The boiling point is increasing. So again, what are we given? We are given letters A to B, and then we are told that between letters A to B, it says consider the graph below that indicates the boiling points of what? So we know that one must be an alkane, and then the other one must be what? The other one must be an aldehyde. So 3.3.1 says identify the homologous series represented by graphs A and graph and graph B respectively. So again, you need to use what? You need to use the table. To say again, London forces is what? Is your triple A. So the first one that is there is what? Is your alkanes. Okay? So already you know that you've got London forces, and then under London forces, you know that you have alkane. The next one was your dipole forces, and then under dipole forces, you have what? You have your Hague. So your Hague was consisting of haloalkanes and then aldehydes, ketones, and what? And esters. So the second one there is your aldehyde. So this one says identify the homologous series that are represented by the following between what? A and B. So then it means that you need to start comparing between aldehydes and the what? And the alkanes, to say which one between the two in terms of strength now will be stronger. Is it going to be the dipole forces for the aldehydes, or it's going to be the London forces for the alkanes? So after determining the strength, it also means what? The one that will have stronger intermolecular forces must also be having what? Must also be having a higher what? A higher boiling point. So letter A will have what? Will have a higher boiling point as compared to letter B. So the one that has the higher boiling point is therefore what? Is therefore the aldehydes, followed by B, which is the alkanes. And we just explained that. We said aldehydes, they will be under dipole forces. Dipole forces have stronger intermolecular forces compared to what? Compared to London forces for what? For the alkanes. Okay. So moving on to the next one, 3.3.2, explain the difference in the boiling points of the two homologous series represented by the graphs A and B. So we need to explain the difference that is there in the boiling points of the two homologous series that is represented by graph A and by graph B. And then it says what? We need to refer to the type and to the strength of the intermolecular forces, and this is for a total of what? This is for a total of 3 marks. So this is for a total of what? Of 3 marks.
Excellent. Excellence is a habit. Excellence is a quality.
2. So what is it that we are going to do? Again, we are going to be stating what we know. So what do we know about the aldehydes? Aldehydes have what? They have dipole forces. Okay, and then alkanes, they have what? They have London forces. Therefore, dipole-dipole forces, dipole-dipole forces are what? Are stronger than what? Than London forces. And therefore, more energy is required to do what? To overcome the intermolecular forces that are there in the alkanes as compared to the alkenes. So again, for these 3 marks, what did we do? We used ice. By ice, what did we do? We said I is what? Is the type of intermolecular force. So what is the type of intermolecular force? We said for aldehydes, it's dipole-dipole forces. For alkanes, we said it's what? London forces. Then, after stating, that is when we compared. So remember, you cannot compare if you are not going to state. So you start by stating the type of intermolecular forces, and then you can compare. So we stated here. By C, then what are we doing? We are comparing. So from there, we know that dipole-dipole forces are what? They are stronger than what? Than London forces. Then, what did we do again? We spoke about the energy. So more energy will be required to do what? To overcome the intermolecular forces that are where? In the aldehydes than in the alkanes. Okay. Then the next one there, so question 5, it says a learner investigates the relationship between the structural isomers of pentane and their boiling points. Okay, so it says a relationship between the structural isomers, okay, of what? Of pentane and what? And their boiling points. And then the results obtained were recorded as shown below. So what do we have? We are given the compounds, and those compounds are the structural isomers of what? Of pentane. And then for those structural isomers of pentane and pentane, what are we given? We are given the molecular what? The molecular formula of the 3 compounds. And then what are we given as well? We are also given the boiling point here on the last what? On the last column. Okay. So again, learners, if you have any questions, you can send your questions to the following WhatsApp number 0635081301. If you have any questions, you can send your questions to the following WhatsApp number 0635081301. Okay. So the first question here says 5.1, define the term homologous series. Okay. So it says here it is a series of organic molecules that is defined by the same general formula and where each member differs from the next by what? By a CH2 group. So already I'm sure this definition, you should know it off by heart by now. Then 5.2, it says for this investigation, write down the conclusion that can be drawn from the above results. So what is the conclusion here? It says straight chain alkanes have a higher boiling point compared to the corresponding branched chains. Okay, so straight chains. So what is it that we can observe here? Remember the question said that we have structural isomers of what? Of pentane. So it means that the pentane is what? Is a straight chain. And then the second one is a butane, meaning it has 4 carbons. And then on position number 2, we will have a CH2 group. And then the last one, it means that we will have what? A total of what? Of 3 carbons. And then position 2, so 2,2 means that on position number 2, we are going to have two. So di means that we are going to have two of the what? Two of the methyl groups. So it means that as we go down, it means that that is where we have what? We have more branches. But as we go up, that is where we have less branches. So this 2,2 dimethylpropane is more branched as compared to this one, and then the pentane is therefore what? A straight chain alkane. So going back to the answer here, it says straight chain alkanes. So it means that we are looking at your alkane, and then we are comparing it to the structural isomers of pentane. So straight chain alkanes, they have what? They have a higher boiling point. So again, if you observe the boiling point on the last column, you will see that the pentane is a straight chain, and that it has what? It has a higher boiling point as compared to the structural what? Structural isomers of the pentane. So hence that's why we are saying straight chain alkanes. So it means we are referring to this pentane. It will have a higher boiling point. So we can see the straight chain alkane is pentane. It has a higher boiling point. What is that higher boiling point? We can see that 36 is higher than what is, or is bigger than what? The 28 and the 10. So straight chain alkanes have a higher boiling point as compared to their what? To their corresponding branch chains. So as compared to these two, the straight chain has what? It has a higher boiling point. So that is what we can conclude from this investigation. Then the next question says, refer to molecular structure, the intermolecular forces, and the energy to explain your conclusion in question 5.2. So it says, yes, straight chain molecules have what? Straight chain molecules have a larger surface area as compared to branched molecules. So remember, we said the branched molecules will have what? Will have a smaller surface area. And then we are saying the straight chain will have what? Will have a larger surface area. So you need to keep that in mind whenever you're explaining an answer on what? On branches. Okay? Therefore, we are then stating what we know. What is it that we know about the three? All of them, they will fall under what? They will fall under London forces, because all of them are what? All of them are alkanes. Remember, London forces AAA, the first one is what? Is your alkane. So all of them, they fall under what? London forces. And then it says London forces in straight chain molecules are stronger than in the branched molecules. So we spoke about this one. If you have a straight chain as compared to a branch, then in terms of the strength, we are saying that the straight chain molecules will have what? In terms of the intermolecular forces, the straight chain molecules will have stronger intermolecular forces as compared to the branched molecules. And then from there, we can therefore talk about the energy. More energy is what is required to overcome the intermolecular forces that are on the straight chain as compared to the branch molecules. Therefore, straight chain molecules will have what? Will have a higher boiling point. So again, even for this one, so for all the questions, even for this one, we followed the what? We followed the ice, but it's just that this one asks for what? For the molecular structure. So that is why, therefore, we started by what? By talking about the surface area, and then from there, we stated the type of intermolecular force. So we said that all of the compounds, they contain what? They contain London forces. Then we compared the strength of the London forces by saying that the longer ones, or the one where we have a straight chain, that is where we have what? Will have stronger intermolecular forces. And we therefore talked about the energy to say straight chain molecules will have what? Will require more energy to overcome the intermolecular forces as compared to the branches. And then the last statement, that is where we were therefore concluding to say that therefore straight chain molecules will therefore have what? Will therefore have a higher boiling point. Okay, then it says here 5.4, what precautions should the learners take when carrying out this experiment? And then you need to give a reason for your answer. So the learners should do what? They must avoid direct heating with an open flame. They should work in well-ventilated areas. And then they must also use what? They must also use a fume hood. And what would be your reason there? It says alkanes are fuels and therefore they are highly flammable. So that is your 2 marks there. So it means that you can get a mark for any of the 3, and therefore for giving your reason there. Okay. So learners, I will leave you with these words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." Thank you very much, learners. I will see you next time, and at the very same place and at the same time. Thank you.